In this session, I'm going to go over the Hi-Fi project. The Hi-Fi project is basically based on this model here that we kind of was using earlier to kind of go through. If we shrink it down a little bit, it's a fairly good size model. And within Eclipse as the IDE to look at the project structure, we also talked about the OA template project and how it's all set up. Hi-Fi follows that to a T. And again, if we go through the source, and then its package name is tmgsc.hi5. Underneath there is the same directory package structure that we were seeing there in the template project. In the template project, we didn't get too much into the controllers just because was setting that up to be able to do in this project, and I want to focus a little bit more on that in this project here. Basically, for the MVC Padron, the control is usually where a lot of your code has to be as far as how everything gets wired and worked together and stuff like that. Since the OA model uses these observable objects that have a lot of the functionality built into them, the controller piece of code is a lot less, and it's a lot of the features and stuff like that's already built into the model, so it's just stuff that that's already there for us. If we look at the server side, on all the controllers that it has, there's controllers kind of to manage everything on the server side from the data source controller, and its job basically is when it starts the application, when the application gets started, its job is for the database connectivity and stuff like that. The Jetty controller is for the Jetty web server, which is used for the web app, and that sets up an SSL connection capability, Java Web Start, servlets, Java Server Pages. The object controller, its job is to manage the controlling processes, custom processes within your model objects. For example, email services and stuff like that. An email needs to go out based on a certain condition and stuff. So instead of building that into the objects themselves, and we want to kind of have that set up so it's kind of behind the scenes, so that whenever the condition arises for an email to go out, there'll be a process there that's basically waiting or listening for that to happen, and it will take care of that. So those are the object controller components of that. So the central object component, its job is to basically create an instance of all of the individual controllers, and each one of those components will then be listening and automating, some additional processing that happens within the model. Another thing that this offers is concurrency type of background processing and executive services and stuff like that, as far as how things are handled in another thread and stuff like that. The RMI server controller, this component allows distributed method calls to be made, custom ones. We talked about some of the distributed components, remote features and stuff like that in the template project. The server controller, its job is to start up the server. So from the time there's the application started, its job is to start all these other controllers. So it's a hierarchy. The server frame controller, its job is for the UI frame window that's being used. And whenever we look at the view or the UI code, it's very just UI centric. It does allow for binding, but in the most case, you won't see any code as far as interaction, how they all work together and stuff like that. So the model itself is bindable, so that handles a lot of that. And then the other side of it is these actual controllers, UI controllers. So in this case, the frame controller handles that. And this is the frame here. So this frame, as far as the data and how everything gets set up, obviously a lot of that comes from the model combined into these components that are here, and then the server controller, the frame controller, its job is basically set all that up, do the binding from the model to the view. And again, it's since the model does so much, the controller really doesn't have to do a whole lot more than just binding them together. The model controller, its job is basically to do pre-selects and stuff like that to load up some of the data, not all the data, just certain data that's known. Let's go ahead and load this up and cast this out. So it'll go ahead and do that. The spell check controller handles everything to do with spell checking, distributed spell checking, managing the dictionary type of stuff like that. The startup controller is what starts the application. Part of its job is figuring out, what do you want to start? Do you want to start this as a server with the UI? Do you want to start this as a server, as a Windows service? Do you want to start as a client? If you're starting as a client, is it starting from the web or is it starting from a desktop? So it knows that. The log controller handles logging related type stuff, so that we're able to capture everything that's going on within the application in these log files at whatever detailed level we need to know, and then from there, we have all the information we need as far as troubleshooting stuff. The about controller gives us information about the running application, about the version it's on, stuff like that. The client controller does very similar things, except on the server side, on the client side. The client controller itself starts up the whole client application. So its job is to basically start up each one of these controllers. The nice part about this hierarchy of controllers is a controller is managing just a subset or a certain amount of functionality. Other things that it doesn't manage is it could either abstract out, or another controller would automatically do that for it. So that's kind of how all this is set up, and this is just kind of from years of practice figuring out how to situate that and line those up, but it ends up being a pretty consistent way of doing it. The frame controller, again, manages the whole frame. Its job is basically to draw out the frame, put the different layout components on there, and then all the UI components, put them on there. Those UI components know what UI components that they need, and they actually put those on. So again, we get this kind of a hierarchy type responsibility chain type thing going on. The client object controller manages the objects in a way that allows us to anything custom just for the client side. For the most part, very little, but it is something that we can put over there if we need it. But again, it's very rare. Usually, our server side's object controller is where we end up moving that code to. And the reason why we don't need this is because the model, again, has all that stuff in there for us. The client spell check controller, its job basically is to give all the functionality of spell checking and also work with the server. So we have a centralized dictionary, and we also have a client side dictionary that could be interchangeable and stuff like that, and how they work together. The file dialog, whenever you have pop-up dialogues and stuff like that, kind of a central place to put those. The login controller manages the whole login process, and part of that is to check the version, make sure that it has the latest version. If it doesn't, download the code. So again, on the client side, it's zero admin. There's no uninstall, reinstall, and all that kind of stuff. PDF controller has features for viewing and displaying and creating PDFs. Report controller manages all aspects of reports: preview, save as PDF, save as an image, printing, of course, and all that. So with those controllers, and using the model that has the application logic and how it's all tied together in there, that kind of just binds it out into a UI distributed application. The data source package basically has one, I think almost always just one object, and it's called data source, and it is the ORM, and which basically this maps out the objects, and this is all generated and from OABuilder. It can be pretty much just use it to always build it for you, and its job basically is to, in this case, it's a JDBC backend, which is a SQL database, and it will create a JDBC OA data source, JDBC, which is, again, uses JDBC to talk to the database. And what this will do is actually map out exactly how the objects worked with result sets. And as far as queries and everything, the queries are done based on the object structure, translate it into a SQL, goes to the back end, returns a result set. That result set then it populates the objects, and this is the information on how it does that. And we'll be talking about data sources when we get more into the OA stuff. But it's all what the server will do is create this data source. It has all the mappings. This is basically then loaded or registered into the runtime of the Java instance, and then whenever any query is done or an object is saved, removed, or deleted, or updated, or anything like that, it will be able to find the data source, in this case the JDBC data source, that works with that class of objects, and then it will know how to persist it to the database. Again, that's from querying, always saving, deleting, updates, and stuff. The delegate package is just a place where we can centralize putting some functionality based on, again, usually a topic, a certain name. In this case, we have a model delegate. So a model delegate is, instead of passing stuff around all over the place, all the delegates are known to be singletons. So a single instance static references and stuff. So these are central places that our code can reach over to and get and call certain methods. The reason why this is important, because otherwise we'd have to be passing this around a lot, and it's nice to have it centralized. The fine line that you have to walk on this is you don't want to put too much into this, so that code ends up being very hard to follow. As far as you have these methods that can be called from everywhere, and next thing you know is you don't know who's calling what and stuff like that. So there's a rhyme and a reason for each one of these and how they're set up. Under this package delegate, there's an OA package. Okay, OA is the name of all the objects, OA objects, and so we'll see under here that there's some delegates pertaining to the OA objects. Basically, what these are for, again, they're still delegate singleton type objects, and what their job is again, this is just design and how this is set up, is I've taken code out of the actual object and put it into a delegate, so it's easier to test and isolate and unit test and stuff like that, and it centralizes it, and its job is basically to do certain things for this type of object. So there is email is the name of one of our objects, and everything in this delegate is something to do with emailing. So here's one called send, so it knows how to send it. So if we look at these other objects, I can know just by the naming that this is functionality for e-cards. If you look at it, almost all of the functions are something to do with the e-cards, or employee e-cards in this case also. Help is our help system, context sensitive help and stuff like that. JSP is our JSP controls, not actual JSP pages, but these are controls that are customized within this application that could be then upgraded to put into the template package later on, that were customized for this application's web pages. And again, we put them in the JSP, and basically they are reusable components that we use within our pages. And a couple of these are probably most likely the image scroller is going to end up into our component set and stuff. The model, again, back to the model view control and the fact that OA has this reactive model, funny word, that has stuff built into it. And if we look at the model itself, each one of these is the actual object, has a model, and the name of it says model. So the address model has it's the model that drives all the objects. The actual objects themselves are under the model in the OA. So each one of the objects that's in the OABuilder object model is here, and we'll do another session on kind of going into detail how these are set up. the model objects themselves, these also include the wiring and how it works with its reference objects. So if we look at the employee object, or employee model, we would see that it has references to all of these other objects. And again, from looking at the model, we can see all of the references that the employee object has. Well, here they are in the model, and it creates these relationships between them, like master detail type relationships and stuff like that, that automatically build into the model, and then our view can bind to these and stuff. Also within the model there's our search model components. So for our search UI, so your inputs and stuff like that that you use for your searching is all put in here. For filters, you can also have a UI for filters that will let you put in inputs that will filter the data based on those inputs. So this is the models for that. Now again, to go back under OA, these are the kind of, I guess you'd call them raw objects or whatever, that define things. So if we look at the employee object here, it's a OA object, which is the base class, but other than that, it's pretty much, here's all the properties, here's all the references. Again, it's got a whole bunch of references and stuff. But this is the POJO-ish type object, I guess, that you'd get to with whenever you have an instance of an employee. This is the information that you would have about that. And again, if you look in the database and you pull up an employee record from the employee table, then you would see all these columns, and then you would see a bunch of foreign keys related to the foreign keys needed for these, or there would be link tables depending on how the relationship's built and stuff. So those are those objects. Each search object that we just talked about, the search criteria that you put in there, is automatically generated and put here. And again, for this application, there's a lot. It's a pretty big model. It's probably a medium-sized model, but you know, when you look at the code, it looks like a lot of classes and stuff like that. Each one represents one of those entities, so it's not like there's extra overhead because we're using OA. It's because if we look at OA template project, you see how there's hardly anything, and it's a full application. With this here, this is expanded because each one of those entities or objects in the model is represented by a class, and then that's represented by its model, which glues them or wires them together, and all the other components and stuff that go with them. We talked about the processes. I don't think we have any. We might do. I guess we do. A process is like a background process or something that'll run. This here is, I don't think this is active or anything right now, but this here is just showing a process that's actually going to use this select, which is then going to select all the employees in the system. This OA select object is a data source independent way of querying and get back result sets. So basically, I can use this OA select, I can do a select, and what this will do is then find the data source, in this case a SQL relational database. It will generate a query to select all the employees, because that's all I'm asking for. I didn't put any where criteria or any criteria in here, and then it loops through each one by calling the next on that. And that's one way the query of the database and stuff like that. Remote. We talked in the template project about how the remote stuff is it has those. It will also have a custom high-five remote. So it's an interface. You define what methods you want to make remote, and then there's the impl. And this is the actual implementation that will run on the server. When the server application starts up, it basically creates this remote object that can be called from a client. The client will then be able to, it has a static method to be able to get, and we'll look at those here in a minute, or maybe we missed those already. Remote delegate. Remote delegate has a reference to all of your remote objects. You can call them just like a local reference or local method, and it will then basically communicate to the server. The code will run on the server and send the result back. So again, it's just a way of distributing out and deciding exactly where you want your code to run. Reports are a list of custom reports. All the OA reports would be here, and this is something that we're expanding out right now. And each one of the objects can be defined what they want for the reports. OABuilder is going to be able to generate those reports, and then they can be customized from there. Servlets, we talked, nothing new there. The view components are for each OA object that's in the model. It has its own object all the way through here. I'm going to create another session that's going to go through exactly how this is created, because it's pretty interesting. It takes the model, doesn't create a CRUD application. It's a lot more advanced than that. It's a lot more, has a lot more features and a lot closer to a fitting all the requirements that you would have. And what it does is it builds out these objects in a component way. So if we look at employee JFC, it's a big class. It's 3,348 lines long, but each one of these is laid out the same all the way through. So basically what it does is it knows all of its references. That's why this class is over 3,000 lines long, because it's got a lot of UI code to be able to talk to, you know, or have the UI components and stuff for all this stuff. And what this will do is all the references for an employee are other entities. Those entities have their own JFC component. Well, all the employee JFC has to do is actually create an instance of one of these other JFC, override any functionality so it gets this custom fit on how it how they're supposed to interact together and stuff like that, and what features are turned on and off. And it makes them really easy to be separately created and used and tested. And then again, when they get created, to be easily custom fit to work together. Each one of them can be ran standalone. So here I'm running this employee standalone. I can go into this, or that's employee type. But each one I could run standalone and see all the information that goes with it. So if we look at employee, so built into the code that's generated for each one of these, it has a way to run it separately. And so we can go through and test this and play around with this. We can see what the search screen looks like. It's automatically connected. So if I create a new one, there we go, a new one, I'm going to go into it. It's going to bring up the editor for employee. And here's all that extra information that goes along with employee. Here's all the property information, and then we get into all of its references to everything else. So again, this is kind of generated into these components. These components have all the pieces parts to then create itself, and then reach out and get the other components that it has references to, and basically have these inner classes that take those components and customize them in a way to overwrite their behavior or customize the behavior to work with the way it's supposed to work with this component. So within itself, that's a really powerful feature. And again, we can get all that for free as far as code generation and without having to write this code. All right, that's it for this session.